Start off by getting the coordinates of the airfoil from the internet or another source. I'm going to use the NACA 63-212 airfoil. So I can search that and pick the first result from airfoiltools.com. I'm going to grab the SALEAG format DAT file and copy everything from the second line all the way on down. Now I'm going to go over to Excel and paste that data in, and it looks nicely formatted, but in fact it's just one block of text. So we're going to have to let Excel break that up. So select the first column, go to Data, and use Text to Columns. Make sure that everything is broken up nicely into the individual columns and hit Finish. Now delete that first blank column. So there's your X, here's your Y. We need to enter zeros for the Z. So 0, and then double click in the bottom right corner to auto-populate all the way down. So we have our trailing edge point, the profile describing the upper portion of the wing, the leading edge, the lower portion of the wing, and then back to the trailing edge. So now we're going to save that as text tab delimited. We're going to call it whatever we want. We'll call it 63-212. And Excel is going to get angry at us, but go ahead and just keep on clicking OK. And close out of that and don't save. Now in Solidworks, create a new part, and then Insert, Features, Curve through XYZ points. Now you're going to browse and find that text file you just created. Open that up. You'll see all of your coordinates in that array. Hit OK, and you've imported your airfoil. Now before going further, make sure to switch from inch-pound seconds to meters kilogram seconds. Alright, now create a new drawing in the front plane. Select that airfoil and convert entities to make a copy of the shape. Now hide the curve to make it less confusing, and then select your curve copy, delete the edge constraint, and move it a bit out of the way. It helps to rotate a little bit to make it easier to avoid accidental constraints on your lines. So what we're going to do is start out by modeling the chord line, starting at the trailing edge and going to a point near but not coincident with the leading edge. Then we're going to draw a second line leading away from that and tangent to the airfoil. You'll see that that tangency constraint has automatically been added. Alright, now we're going to make that forward line and the chord line perpendicular. And that's going to ensure that that leading edge point is coincident with the leading edge always. Now we can define the length of our airfoil. It's important when you do that to make sure that you're defining the actual chord length and not the horizontal length. If you define the horizontal length, then the chord length will change with the angle of attack, and you want that constant. So define the actual chord length of the airfoil as 0.3 meters. Hit OK.